Hello everyone. This video is on the Knewton Alta assignment, section 2.5, part 2, called Complete the Square. So in this video, I'm going to be going over a preview version of the section 2.5, part 2 assignment. Please understand that the questions I see in this video may not be the same questions you see when you work on the assignment yourself. But the objectives should be the same, so the types of questions and how you do them should be similar. So I'm hoping that watching me do these here will help you in some way when you do it on your own. Alright, so here's the assignment page I'm at, right? You won't see the words preview of, you'll just see the title. Got your mastery bar telling you how far along you've gotten. You can see your objectives. Looks like there are 2 objectives in this assignment. And beneath the current objective is a question related to that objective. And at the bottom of every question, you should see a feedback button where you can send feedback to Knewton about some errors you might see in a question if you happen to see anything. You will not have the instructor cheat button. Right, this is for instructors only. But you will have a more instruction button, which can be useful if you're struggling with a particular objective or a particular question. Click on more instruction and you'll be taken to a page with some reading to do or some videos to watch, and then they'll give you questions related to that instruction, and you can work your way through the assignment and progress that way if you want every single time. Nothing wrong with that. Alright, so this first objective, the first question here is on solve quadratic equations by the square root property. Alright, so before I get into this question, let me discuss or tell you about what this square root property is. And it states the following: if you have some expression to the second power, and that is equal to a number, so I'll just say n for number. So you have some expression with a variable squared, all alone, equal to a number. Then this expression is either the square root of that number, the positive square root, the principal square root, or it's the negative square root, because a negative number squared still gives you the same number back, right? Or that same expression is equal to the negative square root of the number. Now they might use the letter x for the expression when you see the square root property in your text, but it's not just working for the letter x. It could be any expression with a variable squared equal to a number, and this property will still hold. Right. So the example they're giving us, the first question, they're asking us to solve the following: negative 2 times x squared plus 112 equals 14. So here's a way you're going to be able to tell when you can use this square root property to solve a quadratic equation. You see I have a variable inside a square. Let's say, inside a square. Right, there's x squared. And then for the rest of it, there is no variable outside that square. All right. All right, I don't see, the only place I see the variable is in the square. And, outside that, there's no other variable. If that's the case, if you're seeing stuff like that happen, then you should be able to solve an equation using the square root property, right? A quadratic equation. So the first thing is to isolate the square. Get that square all by itself. So in this case, I would subtract 112. So we'd have negative 2x squared equals, and then 14, minus 112 would be negative 108. Right? Oh, no. Negative 98. Wow. Sorry. I caught my mistake there. Yeah, 14 minus 112 would be negative 98. And then again, you want to get the square alone, only the variable expression squared. So this negative 2 is not being squared. So I'm going to divide both sides by negative 2. And we get x squared equals, negative 98 divided by negative 2 would be positive 49. Right. And now I have something that I can apply the square root property for, too. Right? See, I have an expression squared, a variable expression squared on one side equal to a number on the other, just like I've written up here. Alright, so by the square root property. Now I'm just going to call the square root property SRP for short. Alright, square root property. So by the square, now I can apply SRP. By the square root property, the expression being squared, x, is either the positive square root of 49, or, again, the expression being squared, which is just x, is equal to the negative square root of 49. And these numbers are known, right? X equals 7, or x equals negative 7. And then, of course, don't forget to check these and back in the original equation. Alright, so I'm going to just do these out loud. When x is 7, 7 squared is 49. Negative 2 times 49 would be negative 98. And then negative 98 plus 112 would be 14. Alright, so x equals 7 works. Alright, that's a valid solution to this equation. And the same thing would go for negative 7, right? Negative 7 squared is positive 49. And then the rest is the same. So, valid solution both. So 7 and negative 7. But this is the key for this objective, solving an equation with the square root property. First, you'll notice that there's a variable in a square, a variable expression inside a square, and there are no variables anywhere else. So then you isolate that square, get the variable expression squared alone on one side and a number on the other, and then you can apply the square root property and simplify the roots. And of course, check your solutions when you're done. Alright, so 7 and negative 7 are the solutions here. Now back on the assignment, again, read how they want you to enter answers. List your answers separated by a comma. Do not enter a plus minus sign, because one's positive 7, one's negative 7. So normally, if you were doing this on paper, you could say x equals plus or minus 7. Right? That would be totally valid. But here they want them separate. So one positive 7, comma, and then the other solution is negative 7. Right? And submit. Now, after every question, you'll be told if you're right or you're wrong, and then you'll be provided with an answer explanation. Please read through these answer explanations, whether you're right or wrong, because if you're right, just make sure you understand why you were right, or that you didn't just get lucky, that you did not, or they could be doing it another way that you like better, And you could try that in the future in this objective. Now, if you're wrong, definitely read through the answer explanations, try to figure out why you were wrong and where you went wrong, and hopefully you can fix your mistakes in the future. Alright, so let's move on here. Alright, so still in that objective with solving an equation using the square root property. So once again, look at this equation here. See how there's an x squared, there's a variable expression to the second power, and then outside that square there's no other variables. If you see that in a quadratic equation, you can try solving with this square root property. Alright, so once again I'll write this out. We got the square root property there. And I'll leave the square root property up and just write it on this new sheet. So the equation we're given here is 3x squared minus 183 equals 9. Right? And as I mentioned before, right, you got a variable in a square, no variable outside that square. So I can try solving this with this square root property. So I want to start off by setting up the equation this way, where I have an expression squared equal to a number. So let's get this expression squared alone, right? Isolate this. All right, so first I'd be adding 183. So I'd have 3x squared equals, 9 plus 183 would be 192. And then, to isolate the square, the 3's not being squared, just the x is, so then divide by 3. Alright, so x squared would be equal to, now 192 divided by 3 would be 64. Alright, 3 times 64 would be 192. Alright, so I'm hoping it's obvious, but now I can apply the square root property. Right, I have my expression squared equal to a number, so by the square root property, right, SRP, the expression being squared, the x, is either the positive square root of 64 or x is the negative square root of 64, right? Either way, you square these, you're going to get 64. And simplifying, x equals 8 or x equals negative 8, right? And these both work. Right? When you square both of these, you get positive 64. Right? They should, and again, going back to the original, they should work, right? And I leave it to you to check it on your own. But yeah, so those are my solutions, positive 8 and negative 8. And again, they don't want us to put a plus or minus 8, right? They want them separate, 8, comma, negative 8, or negative 8, comma 8. It shouldn't matter what order the solutions come in as long as they're both valid solutions. Wonderful. Okay. Next question. All right, so now we're asked to solve quadratic equations by completing the square. Alright, so I think this might be a two-parter, because the first part, they're having you take this equation and write the equation that results when you follow the complete the square method for solving quadratic equations. Alright, so let me talk about that first. Now, you should know how to complete the square from earlier videos on factoring quadratics. So I'm not going to really get into all that. Alright, so first, you're going to get the quadratic and linear term to one side. And make sure the quadratic term, the term with x squared, has a coefficient of 1. That way you can go ahead with completing the square. So that would be like this: x squared plus, and then some number b times x to the first, and then take everything else to the other side equals, again, some number. I'll just put n for number over here. So the quadratic term and the linear term, get everything with x squared and x on one side, just all the numbers on the other side, and make sure the quadratic term has a coefficient of 1. If it doesn't have a coefficient of 1, just divide everything by that. Easy. All right, then complete the square on the left side. I'll just say complete the square. I'm hoping you remember how to do this from previous videos. Remember how to complete the square. You take x squared plus, the bx here equals n. On the x squared and bx, you take half of b, and square it. This gets added to both sides. So b divided by 2 and squared, and again, this it's an equation, so what you do to one side you must do to the other. Now the whole reason for that is so that this left side becomes a perfect square trinomial. You should be able to rewrite it as x plus whatever half of b was, that quantity to the second power, equals, and then again some number over here, right, some constant. And now, right, the whole point of this is to get something you can apply the square root property to, right? You see I have an expression squared equal to a number. So then solve using the square root property as I showed you earlier in the video. All right, SRP, square root property. And of course, check your solutions, right? Check your solutions. All right, so let me show you, an example with some actual numbers here. The question they gave us is the following. We're asked to, say we have x squared plus 16x plus 60 equals 0. Now, I know that you can probably solve this one by factoring, but we're going to do this another way. Right? The complete the square method, I'll tell you this right now, this works on any quadratic equation. Factoring doesn't. Sometimes a quadratic is prime. Sometimes a quadratic polynomial can't be factored. But this complete the square method works on any quadratic equation. You can always use it to solve a quadratic equation. So that's why I prefer it, actually. So that first step was, get the quadratic term and the linear term, the x squared plus 16x, to their own side, and then then all the constants on the other. So I'm just going to subtract 60. Right, so I have 0 minus 60, or negative 60 on the right. And make sure the quadratic term has a coefficient of 1, which this one does already. Right, so quadratic term, linear term on their own side. Quadratic term has a coefficient of 1, constants on the other, numbers on the other. All right, now comes the complete the square part. Remember, you take half of b, as I wrote here. Well, that's half of 16. What's half of 16? That's 8. And then you square that. Right? You take half of the b squared, which would be 64. And you add this. And you can't just add it to the left side, right? It's an equation. So I add to the right side as well. I'm adding 64 to both sides. Now the whole point of this is so that the left side becomes a perfect square trinomial. This will actually factor to x. It's always just the variable plus whatever half of b was, which was 8, squared. X plus 8 times x plus 8 is x squared plus 16x plus 64. And on the right side, negative 60 plus 64 is positive 4. And this is as far as we go for the first part of this question. I'm pretty sure they're going to have us solving for the second part, but we have the x plus 8 quantity squared equals 4. That's this last option here. All right, and then like I said, when I hit continue, I'm pretty sure they're going to have us solve the equation, right? Moving down, say now actually solve the equation for x. So now we apply the square root property, right? Solve using SRP, the square root property. So I mean, by the square root property, this expression being squared, right, x plus 8, is either equal to the positive square root of 4 or the x plus 8 is equal to the negative square root of 4, and then we solve each of these equations for x. So here is x plus 8 equals positive 2. Subtracting 8, get x equals negative 6. There's one solution. And don't forget to check it. I'm going to leave that to you. Go back to the original equation and plug in negative 6 for x and see that it makes it true. And the other equation would be x plus 8 equals negative 2, and then subtracting 8, I get x equals negative 10. And that should work as well. Again, go back to the original equation. Please check your solutions. But there they are, negative 6 and negative 10. And they want us to enter those with a comma separating them again. So negative 6, comma, negative 10. And don't put x equals, right? They don't want that. Right. Submit. Wonderful. Okay. But yeah, again, I like this complete the square method for solving quadratics because once again, you can use it for any quadratic. All right, so let's move on. All right, so we're back to the square root property. Once again, just getting the variable expression squared, that expression, that square by itself. Let's go back to some paper here. The equation we're given this time is negative 2 times x squared plus 122 equals 24. And you see a variable in a square. There aren't any variables outside that square, so I should be able to solve this with the square root property. Let's get that square alone, right? So first I would subtract 122. That'd be negative 98. Again, this is kind of similar to a previous problem, right? Because 98 plus 24 would be positive 122. And then dividing by negative 2 to get the square alone at positive 49 again. Right? So the solutions are 7 and negative 7, right? By the square root property, x is equal to the square root of 7. Sorry, the square root of 49. It's going to be 7 eventually. Or x equals the negative square root of 49. So x equals 7 or x equals negative 7. And again, don't forget to check these back in the original equation. I'll leave that to you. All right, so here x equals, again, leaving a comma between them, 7 comma negative 7. There we go. All right. All right, so this should be the last one in the square root property. All right, you know what? I'm just going to do this one out loud. If I would first subtract the 130. All right, and 130 minus 22 be 108. So that's negative 108. And then divide that by negative 3. All right. So a negative divided by negative would be positive. And that'd be 36, right? 3 times 36 is 108. So I'd have x squared equals 36. By the square root property, x would be the positive square root of 36 or the negative square root of 36. So positive 6 and negative 6. And again, you can check those if you wish. Great. All right, so that objective's done. All right, then the other one, all that's left is to complete the square again. All right, now this one a little, got to do some multiplying first before I can complete the square. Alright, so let me write this out. So we're solving for u. Right? So we have u minus 14 times u plus 10 equals negative 104. Right? Now notice this is a product equal to negative 104, not a product equal to 0. You cannot use the zero product property here, right? And split them up. It's not 0 on the other side. So in order to complete the square, though, remember the first step was to get the quadratic term and linear term on one side and everything else, all the numbers on the other. So I need to get quadratic terms and linear terms. So let's multiply this stuff. So u times u is u squared. Then you have plus 10u minus 14u. That'd be minus 4u. And then minus 140, right, equals negative 104. And then I would add 140. So we have u squared minus 4u, and then negative 104, plus 140 would be positive 36. And, now I got what I want, right? The quadratic term and the linear term are on their own side, constants on the other. The coefficient of the quadratic term is 1. Again, if it weren't 1, I would just divide everything. Now, if it were 2, I would just divide everything by 2. Now complete the square. Now this time b is negative, right? B is negative 4. Half of negative 4 is negative 2, but then you're going to square it to make it positive again. Negative 2 squared is positive 4, and I'm going to add that to both sides, right? Positive 4. And now this side got, the quantity u minus 2 squared, right? It's the variable plus whatever half of b was. Half of b was negative 2. That quantity squared equals, and then 36 plus 40, did I say 40? I added 4. Why did I add 40? I added 4 to both sides. 36 plus 4 is 40. I think that's why I wrote 40, because I knew the result would be 40. Okay, and now I have an equation that I can solve with that square root property, right? There's a variable expression inside a square. There's no variable outside that square, and I got expression squared on one side, number on the other. So by the SRP, right, the square root property, this expression being squared, u minus 2, is either the positive square root of 40, which simplifies to 2 times the square root of 10, right? It's the square root of 4 times the square root of 10. Or the u minus 2 is the opposite of that, negative 2 times the square root of 10, right? Negative square root of 40. And then I would add 2 to both sides to get u alone. U equals, if I add 2, that'll be positive 2, and then plus, you have a positive 2 times the square root of 10. And this is one solution. I know it looks funky, but you don't put these together. This has no square root attached. This has a square root attached. Right? Can't put them together. Or, and then same thing over here. If I add 2, I'd have positive 2, and then a negative 2 root 10. Right? Negative 2 times the square root of 10. And once again, you can't combine these. That's it. So the solutions to this equation are 2 plus the square root of 10. 2 plus 2 times the square root of 10, and the other one's 2 minus 2 times the square root of 10. You can check these. Right, you can check these. Now, let me show you a way we can check them. Right, since these aren't imaginary, right? They don't have I in them. I can go to that Desmos calculator. Right, and what were the expressions? It was one was u minus 14 times u plus 10. And you know what? I'm just going to change u to x because I don't want to add a slider here. F of x equals, the other side was x minus 14 times x plus 10. And let's see what we get. Hopefully we get negative 104 when I plug in one of these numbers. Right? I want the value of this expression to be negative 104 when I plug in these numbers? Well, let's see. What is f of 2 plus 2 times the square root of 10? And you see it's negative 104. And what is f of 2 minus 2 times the square root of 10? It's also negative 104. So both of those are totally valid solutions. They make our equation true. You would get negative 1. And you can do it by hand as well, obviously. All right, but I'd rather not right now. All right, so back in the assignment, right, how I'm going to enter this is, again, they don't want a plus or minus. They want your separate them with commas. So 2 plus, oops, I forgot the 2. 2 plus 2 times the square root of 10. Then get out of there, hit comma. And then 2 minus 2 times the square root of 10. And that should be good. Both of those are perfectly valid solutions. Great. So you see, that was an example of a quadratic where I couldn't have solved it by factoring. Right, but I can solve it with this complete the square method. All right, again, please read through your answer explanations. All right, so I should have just one more of these. All right, so this one's real nice. See, the quadratic term and the linear term are already on their own side. And the quadratic term already has a coefficient of just 1. So I should be able to jump right into completing the square here. Right. So we have m squared plus 8m. And then I'm going to leave some space because I can complete the square right now by doing my addition. Half of 8 is 4. 4 squared is 16. So I'm going to be adding 16 to both sides. Now again, the reason for doing this is so we create a perfect square on the left. This is m plus whatever half of b was. It's m plus 4, that quantity squared. And then negative 3 plus 16 is positive 13. And now I can apply the square root property, right? I have an expression squared equal to a number. So by that SRP, square root property, this expression being squared, right, m plus 4, is either positive square root of 13 or m plus 4 equals the opposite of that, negative square root of 13. And then I'm just subtracting 4 from both sides. So over here on the left, if you subtract 4, you'd have a negative 4, and then you got a positive square root of 13. And again, these don't go together in any way. That's one solution. And over here, subtracting 4, you got negative 4 and then a negative square root of 13 term. Negative 4 minus the square root of 13, there's your other solution. And once again, you can check by hand, go back to the original equation, right, without the plus 16s, plug in these values for m, and you can do it by hand or with a calculator and check that you get a true solution, and I'll put little check marks here to remind you to check. But they should be good. I know I feel like I did everything correctly here. So one solution is negative 4 plus the square root of 13. Then get out of the square root, comma, negative 4 minus the square root of 13, and that should be good. Hooray. Alright. And once again, please read through your answer explanations. Alright, so that should be it for the preview version of this assignment. As I said at the top of the video, please understand that the questions I saw here may not be the same questions you see when you're working on the assignment yourself, but the objectives are the same, right? The types of questions, the way you do them should be similar. So I'm hoping that watching me go over these examples here help you when you're working on the assignment yourself. And thank you very much for watching.